part two of soils. This one is on soil productivity. And what that means is how the soil behaves to be a good growing substrate. Like, what do we need to make soil a good growing substrate? Now, what we need the right kind of soil. We talked about the fact that the mixture of soil, the sand, silt, and clay, are really important. And I'll explain a little bit more about why that's true later. We also need to know what kind of nutrients are available within the soil itself. So remember that leaves perform gas exchange. So we have carbon dioxide coming out in, and oxygen going out, and the opposite is true. So the gas exchange, remember plants also do cellular respiration, so they need to take in oxygen as well. And they do most of that at night, and then they take in the carbon dioxide during the day. But the roots of the plant perform an amazing service. So what they're there to do is to take in, first of all, water. And the second thing is nutrients. Now, nutrients include all of the things that a plant is going to need to grow. So think about the fact that we're more than just carbon and hydrogen and oxygen. We're also nitrogen and phosphorus and potassium. All those things we looked at in our cycling, we are part of that. So the big eight that we talked about in the first part of this unit are part of what we are as organisms on this planet. So there's some tests that we can perform to find out if soil is productive or not. So there's two different categories here. The first one we can do are physical test. So physical test. And then we can also do chemical test. Now, our physical tests are going to be things that we can tell a lot about the soil itself, the makeup of the soil itself. And so we can use a lot of our senses in order to make this happen. We can try to find out the texture of the soil and the consistency of the soil. So when we talk about that, we know that sand is very loose and what they call friable. It breaks into pieces, right? Clay, on the other hand, think about what we use clay for. We mold it, we make it into pots, we do all kinds of things with clay. Because it is very malleable, it's stretchy, you can mold it and make it into whatever you want. So when we look at how the composition of the soil itself, we can put it through several tests. And the first one is texture, and we can do that by feel. All right, so you can just put it in your hands and you can run it around and you can determine if it's gritty or if it's smooth, or if it has any other kind of properties to it, and then make some determinations about it. One of the other tests that they do in soil science is called the ribbon test. Now, the ribbon test is where you do the same thing. You put it in your fingers and you can actually squeeze it. And if it makes a ribbon, then you know it's got a lot of clay in it. So the ribbon test is one that they do quite frequently when it comes to soil testing. One that you've done is the particle size distribution. So we remember this is the one where we put it in a jar and we added water to it, and then we let it settle down. And when it settled into layers. And those layers are based on the particle size. So the heavier particles, the sand, is going to sink right to the bottom. The medium-sized particles, the silt, are going to be in the middle. And then the finer particles, the clay, are going to be up on top. Now, above that, you're going to have your humus. Once again, humus is organic material, and that organic material most of the time has a lot of air pockets in it, so it's going to float across the top. All right, some other things we can do is we can look at capillary action. And capillary action is how well water is able to be taken up through the root system or through the soil. So capillary, remember, comes from the bottom up. And so we would be able to see how well that happens. Now, a soil might be able to take water up very quickly, but it may not be able to hold on to very much. So something like sand, for example, isn't going to be able to hold on to a lot of water. And if you think about it, a lot of it goes back to particle size. So remember, sand, if we have sand here, sand has great big particles. Okay, and what this means is that because it does, its surface area is not very good. All right, remember, the smaller the particle, the more surface area you have. Whereas with clay, you're going to have itty bitty particles. They're going to be very, very small. And what this allows for is it allows for water to adhere to those particles a lot more. So you get a lot more surface area with clay, and it's going to pack in there. Now you've got a lot of pore space with sand, but the clay itself is going to be able to take in and absorb more water. All right, and finally, permeability. Permeability is how well water drains, right? So we have capillary action coming up, and we have permeability, water going down. So can water permeate? And just the opposite is true here. So with sand, your percolation or your permeability is going to run right through. It's going to be very high. You're going to get a lot of permeability, whereas with clay, it's going to take much longer for the water to be able to drain through those small particles. Okay, so that's your permeability. Okay, our chemical tests, on the other hand, now those are just a few. That's not all of them, but it's enough. Our chemical tests. So what are we looking for with soil? The first thing we're looking for is pH. So we want to find out what the acid bases are in the soil. And of course, neutral is the best for soil. We want a good neutral soil. And I'll explain why here in just a minute. The next one, so we want a good pH. If it's slightly acidic or slightly basic, that's usually fine, but anywhere closer to neutral is good. And then the next thing we're looking at is our macronutrients. So these are the ones that are absolutely essential for plant growth. And there's three big ones. We have nitrogen, and we have phosphorus and potassium. Those three make up the commercial fertilizers. So when we do this, commercial fertilizers contain those three essential nutrients. Okay, that's what's in it: nitrogen, potassium, and phosphorus. Now we can test for those. If we were in here, we would have 4 ways of being able to look at the nitrogen content, the potassium content, and the phosphorus content. And we could tell if the soil is depleted of those nutrients or if they're there enough. The other thing we can do is we can look for ion exchange capacity. Now this kind of goes hand in hand with the nitrogen, phosphorus, and potassium, because what you're looking for is, are there the presence of ions in the soil, and can the soil hold on to those ions? So when we look at clay, for example, clay is able to hold in those ions. So we're back to the amount of water that's there, and also the ions that are present within the soil. So what ions are we looking for? There's some really important ones. The first one is we are looking for our nitrate. Okay, so our NO3 with a negative charge. And this one is big. So if you remember from the nitrogen cycle, Nitrogen can only be taken in when it's in by a plant when it's in its ionic form. And the reason is because of the cell membrane. So if you'll recall from biology, I'm going to kind of draw this out here real quick. I don't know if that's good enough. Okay, the cell itself has what's called binding sites, right? So some things pass through a cell membrane pretty easily. Remember from, from if you have water, of course, it's going to go through with, what's that process called? Where it just flows right through, right? Depending, I blanked. Y'all know what I'm talking about, right? Where water travels across the membrane. It starts with an M, and I've blanked. Okay. Anyway, let's move on. So what we have on the cell, though, is we also have binding sites, and these binding sites are charged. They're either negative or they're positive. So what that means is that the NO3 can come in here and it can bind in with a positively charged binding site, and then it can be uptaken by the cell. Potassium can also, but it's got a positive charge. And another one is our phosphorus. It also carries a positive charge. So each one of those have to have some sort of charge. Well, the soil itself is able to hold in those ions. And so in the lab, we looked at the differences between a negative charge and a positive charge, and how different soils have different types of ion exchange capacity. So clay has a very high negative ion exchange capacity. Okay, pH. So why is pH? Those are your main ones, right, for your chemical test. Why is pH important? Okay, so what happens with pH is that you'll remember if something has a high pH, it usually has a lot of, so let's say you have high pH. That's anything over 7. Your high pH means that you're going to have a lot of these guys, right? So you're going to have a lot of negatively charged ions in there. If you have a low pH, and remember low is acidic, this is basic, right? And if you have a low pH, a very low pH, you're going to have a lot of these guys. And that's going to be acidic. Now, why this is a problem is that they basically start to be in competition with your charged ions over here. So in other words, if you have a lot of OHs, what are they going to bind with? Well, your OH is going to, with that negative charge, is going to bind readily with your potassium. And it's going to form KOH. Well, if it does that, now that ion is no longer available to the plant. So it essentially depletes you of your potassium. Okay. Now on your low pH, the same is true here. You have a lot of negative or positive ions, and they're going to bind with your negative ions. And what that's going to create then is HNO3, right? And now we have an acid in the soil. Once again, it is depleted. So you want a nice neutral pH so that you don't have this happening. You want those ions to remain in the soil. So that's why you're going to want to do that. Okay, now the question is, what if our soil has got issues? It's got problems. What are we going to do? Well, we're going to do something called amending. We're going to amend the soil. This is how we fix soil issues. And it could be all kinds of different issues, right? We could look at whether our soil makeup, right, the particles are right. We can also look at whether or not our pH levels are good, whether our ions are present that we need. All of those are ways in which we can determine if we need to amend our soil. So how do we do that? Well, let's say, for example, that you have a lot of clay in your soil. All right, what's wrong with that? High clay. Well, one of the problems with high clay is that it is too hard for water to permeate. Now it's good because it's holding in a lot of nutrients and it's holding in water, like the plant's going to have a longer time to hold on to it. But if we have too much clay, it's going to get hard, and then the plant roots can't get through. All right, so it's too hard for water to permeate and too hard for plant roots. Now, some plants are well adapted to it. For example, here on the prairie, Blackland Prairie, a lot of our native grasses have roots that are they're like wires, all right? And they're meant to be able to penetrate that clay. So they can do it, but a lot of others that we're trying to grow for food, for example, aren't going to be able to do it. Now, the good news is, remember, clay holds nutrients. So it's got that going for it. And water, so they're not going to dry out too quickly. All right, what about sand? What if we have high sand? Well, what will happen here is, remember, it's got high permeability. All right, so high permeability but the problem with high permeability is that it can't hold water and nutrients. So, if you're trying to grow food in the desert, you're going to spend a lot of money. You're going to spend money on water and you're going to spend money on fertilizer because it's just not going to happen. It's going to run through too quickly. So it's a fool's game to try to do this in the desert. It's not appropriate for that. People still do it, but it's not really appropriate. So how do we fix these problems? What if clay is too high? How are we going to amend this? Well, the way we're going to amend it is we're going to have to add something to it. What do you think we're going to add? Well, you got a couple of options. The first one is you can add sand. All right, so when you add sand, it's going to help to loosen up that clay. But it's kind of problematic because if you've ever done any sort of like concrete work, essentially you're putting clay and sand together. So it's not always the best answer. There is something else that you could add that would really help to loosen up the clay. So that's the whole goal. And that is you could add humus. Now remember, humus is organics. All right, so what kind of organics are we talking about? We're talking about either compost or mulch. And I'll kind of go over the differences here in just a minute. So the nice thing is that not only are you loosening up that clay soil, but you're adding something in. You're adding in nutrients. So what this acts like is a slow action fertilizer. Okay. So you get a double whammy. You get 2 for 1, a twofer. Okay, so it's a slow acting fertilizer. What if your sand is too high? What do you think you could add? Yes, you can add clay. So you could come back and put clay or silt into your soil, right? You could do that. But guess what? You can add something else. You can add humus. Isn't that neat? So why would you add humus? Well, because humus is sort of like the magic bullet. Not only does it loosen up the soil, it puts air pockets in there. It also kind of it loosens the soil. It also absorbs a lot of water. So humus can hold on to water, and in that way, it can actually make the water content of the soil better, of the sand. So add humus. And what are the benefits there? Well, same thing. Not only are you able to add something that's going to slow the water down, the permeability, but you're also going to put the nutrients back into the soil. And then the plants are real happy. They like that. Okay. But let's talk about humus for just a second. So why humus? And I gave you a couple of reasons. All right, so why humus? Well, one, it loosens soil. Okay, so we looked at that with the clay. Loosens it up. But it also does this. It adds air pockets. Now, air pockets are really important because, especially in a lot of clay, you don't have enough oxygen in there, and your plants can actually drown if they don't have enough air. So the humus adds to and actually helps increase the airflow within those roots so that they don't drown. So air pockets for gas exchange, and that's really important. Okay, another thing is that it helps water absorption. So we talked a little bit about that, right? It helps to be able to absorb water and give yourself a fighting chance to have more water in the soil. Okay, and it also adds organic matter. And the most important thing here is that it puts in nutrients, right? So it adds nutrients. And the nice thing is that it's not just the macronutrients, right? Your phosphorus, your potassium, and your nitrogen. It also puts in the micronutrients as well. So what are a micronutrient? Things like calcium and magnesium and sulfur, and the list goes on and on and on. So not only are you getting a lot of macronutrients, but you're also getting your micronutrients as well. And what this does, but it's slow acting, right? So slow with the nutrients. So you wanted something to happen really fast, put yourself some commercial fertilizer on there. But if you want to do the most good for your soil, you need to start putting humus in there, or your organics. Now, it comes in two varieties. First of all, it comes in compost. So compost is like your when we take yard waste and kitchen waste, and we let it kind of heat up, and we let the bacteria and the other decomposers go to work to start speeding up the process of decomposition. And when we do that, it allows for the nutrients to be returned back to the soil a lot quicker. So compost speeds up the process. That's the first thing. The other thing that it does is it allows you can mix it in. So it mixes into the soil. All right, so it gives you a real nice, rich soil. The other thing you can use is mulch. Now, what mulch is, mulch sits on top. We do a lot of tree bark, they'll take wood and chip it up and make it into a mulch that you can put on top. Now, mulch is really good for a lot of other reasons. Now, it's going to be slow acting to put the organics back in the soil, but it's going to do some other things as well. First of all, it can be protective. And what's it going to protect against? It's going to be protective against erosion. So wind is less disturbing for it, and water as well. So it's not going to wash your topsoil away. It's going to keep it intact. So it's very protective. The other thing is it preserves your moisture. And it also acts as a good weed control. So the weeds have a harder time germinating and coming up through the mulch. So it slows the process down. So you can't go wrong with it. You really can't. It's good stuff. All right, we just got a couple other things and then I'll be done. What else are we going to amend for? Well, what if your soil is too acidic? What do you think we'll do? Well, we'll add a base. So what kind of base are we talking about? The big one here is lime. Now, if you'll recall, limestone has lime in it, and it has a higher pH. All right, so it's pretty easy to find. Crushed up lime, you can put it on. And what we're looking for here is your CaCO3. So our calcium carbonate is the basis of lime. What if it is too basic? Add a base. Add an acid. And one of the typical ones that gets added here is sulfur. And sulfur comes as a mineral, and they can just sprinkle that, mix that into the soil, and it takes care of it. There's something else you can do. You can not amend it at all. You can actually plant according to the soil. So plant things adapted to that pH. And there are all kinds of plants out there that prefer it more acidic and some that prefer it more basic. So that's one thing you could just do is just like, well, maybe we don't need to amend it. Maybe we can just go with whatever we have and plant according to the environment. Wow, imagine that. It could transform our whole world. Who knew? Sorry. Okay, so now we also have a problem sometimes, not just with what's in the soil, but where we're trying to farm. So if you'll remember from the lab, one of the things we have trouble with is that some of our land, though the soil may be pretty good, maybe we have problems with erosion, right? So there's several things we can do. How to prevent, and we'll talk more about this in our next unit, but I'm going to give you a couple right now. How do we prevent erosion? Imagine that you've got a slope. So you're trying to farm on something that's, like slope like that. Here's what you could do. You can actually cut the land and make it to where it is more farmable. And so what they'll do is they'll basically start making steps like this. And this is called terracing. So what they'll do then is they'll put those like that, and then you can grow up on these levels. So we see terracing a lot with like rice farming, but I have cousins that are cotton farmers. They do this all the time. They go out to the terraces and they say it just like that, terraces. Okay, so that's one thing you could do. Another thing, and that's basically, this works really well with stopping water. All right, water flow is one of the big concerns. Another thing you can do is there are wind, right? How do we stop wind? Well, we can do things like plant tree breaks. So in other words, the trees are going to slow the wind down so they can just basically act as a big barrier. We can mulch, right? So we've already talked about that, how you can just put some mulch down, and that's going to keep the wind and the water from carrying your soil away. One that's super, super important is you can plant cover crops. So a cover crop, whenever they come in, they'll do what's called a cash crop or a money crop. Let's say your money crop is wheat, and you plant your wheat. Well, then when the season's over and you come and you harvest it all out, you need to put something on that soil right away, because the wind is going to come in and whip it, and the water is going to carry it away if you don't have it. So then what they'll do is they'll put another crop down, and I'll tell you a little bit more about that in the next unit as well, why cover crops are important and what some good cover crops are. And then another one is no-till. And no-till basically leaves soil intact. So they may come and harvest the stuff across the top, but then they leave all the roots in the soil. And this is important because one, it leaves the organics in there. And then the other is those roots allow the soil to hold steady while still keeping them from getting compacted to each other. Okay, and that is all you need to know about soil. Thanks.